In this video, we are going to talk on coordination compounds. Before that, let me introduce myself. My name is Iqbal, roll number 07. In the beginning of this chapter, we will come to know the metal ion which is present inside this substance. In chlorophyll, we have magnesium. In hemoglobin, we have Fe, that is iron. And in vitamin B12, we have cobalt as a central metal ion. Next, we are going to talk on very important theory which is given by the Werner's theory, which is basically called as Werner's theory. He proposed that central metal ion consists two valencies, that is primary valency and secondary valency. The primary valency is always written outside the square bracket, whereas secondary valency is always written inside the square bracket. Secondary valency is always non-ionizable, whereas primary valency is ionizable. So we are going to talk on some important terms related to the coordination compound. First one is ligands. By looking at this example, we will come to know what do we mean by the ligands. Ligands are nothing but the molecules or ions which are directly attached to the central metal ion is called as ligands, whereas the coordination entity and sphere is nothing but the molecule or ion which is directly attached to the central metal ion, and along with this central metal ion, the whole thing is called as coordination entity or coordination sphere. Coordination number. Now, coordination number is nothing but the ligand donor atoms which are directly bonded to the central metal ion, and coordination number is nothing but the secondary valency. In this example, we will see that here 6 is written, and that is nothing but the secondary valency as well as the coordination number. Next is coordination polyhedron. Based on the coordination number of sites by which ligands are attached to the central metal ion. Based on this, we have three types of denticity, that is unidentate, polydentate and bidentate. Unidentate meaning the ligand is attached to the central metal ion by one side, whereas bidentate meaning by two sides, and polydentate meaning ligands are attached to the central metal ion by many sides.
Hi, my name is Mayuresh Patil and I am going to start with topics: coordination number, coordination sphere, coordination polyhedron, oxidation number of central atom, homoleptic and heteroleptic complexes. Coordination number. The coordination number of a metal ion in a complex can be defined as the number of ligand donor atoms to which the metal is directly bonded. In short, the number of ligand donor atoms to which the metal is directly bonded. It is called a coordination number. For example, in this given complexes, their coordination number is 6 and another is 4 respectively. Similarly, in the complex ions, those are given in the slides, the coordination number of both Fe and CO is 6 because C2O4 and ethane 1,2-diamine are didentate ligands. It is important to note here that coordination number of a central atom is determined only by the number of sigma bonds formed by the ligand with the central atom. Pi bond, if formed between the ligand and the central atom or ion, are not counted for this purpose. Coordination sphere. The central atom or ion and the ligand attached to it are enclosed in square bracket and it's collectively termed as the coordination sphere. The ionizable group are written outside the bracket and are called counterions. For example, in the complex given, the coordination sphere is FeCN6 -4 and the counter ion is K+, K positive. Coordination polyhedron. The spatial arrangement of ligand atoms which are directly attached to the central atom ion defines a coordination polyhedron about the central atom. The most common coordination polyhedra are octahedral, square planar and CONH3 whole bracket 6 raised to 3 positive is octahedral, NiCO4 is tetrahedral and PtCl4 raised to 2 negative is square planar. The oxidation number of central atom in a complex is defined as the charge it would carry if all the ligands are removed along with the electron pairs that are shared with the central atom. The oxidation number is represented by a Roman numerical in parentheses following the name of the coordination entity. For example, oxidation number of CuCN4 raised to 3 negative is +1 and it is written as CO Roman number 1. Homoleptic and heteroleptic complexes. Complexes in which a metal is bound to only one kind of donor groups. Example CONH3 whole bracket 6 raised to 3 positive are known as homoleptic complexes. Complexes in which a metal is bound to more than one kind of donor groups. Example CONH3 whole bracket 4 Cl2 raised to positive are known as heteroleptic.
Hello everyone, my name is Grishma Dhuri, class 12, science A. In order to write the IUPAC name of the coordination compounds, we have to know some rules. So now we will see rules for naming coordination compound. First, order of naming the coordination compounds. If the complex is a cationic complex, so the complex part will be written first, followed by the anion, which is a complex counter ion. If the complex is anionic complex, first cation will be written, followed by the anion. Second, naming coordination entities comprises of ligands and central metal atom or ion. Ligands are written first, followed by the central metal atom or ion. Third, names of ligands. Anionic ligands end with suffix O. For example, F negative fluorido, Cl negative chlorido, Br negative bromido, I negative iodido, NO2 negative nitrito, and ONO negative nitrito O, OH negative hydroxido, Cn negative cyanido, CO3 2 negative carbonato. Cationic ligands end with suffix IUM, for example, NO positive nitrosonium, NH2 NH3 positive hydrazinium, NO2 positive nitronium. Neutral ligands are written as examples CH3 NH2 methylamine, NH2 CH2 CH2 NH2, ethylene diamine or ethane 1,2 diamine, C5H5N pyridine, H2O that is water is written as aqua, NH3 ammonium which is written as amine, NO nitrosyl, CO carbonate. 4. Order of naming the ligands. When a complex is a heterolactic complex which is made up of more than one type of ligands, the ligands are written in alphabetical order. Order of naming the ligands. Ligands are named in alphabetical order. The number of ligands.
My name is krutika. I am roll number 8. Today we will see how to write IUPAC name for a coordination compound. We have already learned rule to write a name for a coordination complex. So we will write IUPAC name with the help of example. The first thing we need to do in a complex is to identify which is coordination complex. When we write down atoms in a square bracket, that is coordination entity. Here in this example, square bracket is written first. That means coordination entity is a cationic complex followed by counter ion which is outside the coordination sphere. To write the coordination entity, we first need to write ligands. So here there are two ligands, chlorine and NH3, followed by central metal ion or atom. When we name the ligand, chlorine is written as chlorido and NH3 as amine. So one point to keep in mind that when we write IUPAC name for a compound, it follows alphabetical order. So as there are 5 ligands of NH3, it is written as pentaamine, followed by chlorine which is written as chlorido. Then comes central metal atom, it is cobalt. We have to find the oxidation state of cobalt. The oxidation state of cobalt, X, which is the cobalt, plus 1 into minus 1 of chlorine, plus 5 into 0 of amine, plus 2 into minus 1, that is counter ion, which is 2 chloride is equal to 0. X minus 1 plus 0 minus 2 is equal to 0. So X is equal to plus 3. Oxidation state of a cobalt is plus 3, which is to be written in a Roman numeral. Since counter ion is there, we have to write it after the Roman numeral, that is chloride. We do not write counter ion as chlorido. Only when it is ligand we write it as chlorido. In this case, it is an anionic complex and central metal ion is written little differently. It ends with suffix "ate", Lit. So when we find oxidation state of nickel, we get it as +2. When we writing a name, it is going to be tetra, as there are 4 chlorine, and chlorine is written as chlorido as it is ligand, and nickel is written as nickelate because it is an anionic complex, and in bracket we write 2 ion.
Hello, myself Nagesh Nagvekar from 12th Science A, roll number 10. Now let us see some more example of IUPAC nomenclature of coordination compounds. So here potassium is the counter ion and square bracket represents the coordination entity. No matter cation is complex or counter, it has to be written first. So when writing name, potassium will come first. Potassium, which is now followed by complex, and complex is now going to be anionic complex. So to write the complex, we start with writing the names of the ligands. We have 2 ligands here, oxalate, which we will call oxalato, and chloride called chlorido. It will be as per the alphabetical order, so chloride will come first. First, there should be always space between counter ion and complex. So this is going to be dichlorido followed by oxalate. This is going to be dioxalato, and then comes the central metal atom, which is cobalt. Since this central metal atom is a part of an ionic complex, we have to write the suffix "ate". In the bracket comes the Roman numeral, which is the oxidation state. So to find oxidation state, as we know that potassium is +1, so 1 into 3, which is 1 into 3 plus oxidation state which we supposed to found taken as X plus plus oxalate is negative, so -2 into 2, which is -4, plus chloride is negative, so -1 into 2, which is -2. That means x will come, that means the oxidation state will come to be as 3. So the oxidation state of cobalt here is 3. So the name of this compound comes to be potassium dichlorido dioxalato cobaltate 3. Now here is the second example of writing iambic nomenclature of coordination compound. So here chromium is the central metal atom and ammonia and water are the ligands. So let's find oxidation state of chromium. Since coordination ion is present, it is already balancing the charge on coordination entity. Chromium is coordinately linked with ammonia, which is a ligand, and also water, which is also a ligand. Chloride is a coordination ion, which is negatively charged. With the help of that, we will find oxidation state of chromium. We will take oxidation state of chromium as X. So by calculation, oxidation state of chromium comes to be +3. Now let us begin writing the names. Writing the coordination entity, we have to start with the ligands. The names of the ligands we will be written in alphabetical order. In this, amine and this is aqua. Both starts with same alphabet, so we'll go for the next alphabet, AM or AQ, AM and AQ. So AM will come first. Since there are 3 ammonia given, it will be written as triamine, 3 water, so triaqua. It is a cationic complex, so it will be written as chromium. In bracket we have to write the oxidation state, that to in Roman number 3, followed by the counter ion, that is chloride. So the name of the coordination compound comes to be triamine triaqua chromium 3 chloride.